Hi everyone, and welcome to Learning Objective 4 here in Module 10. And the objective here is to demonstrate the use of predictive statistics and analytics visualizations. So we're going to work exclusively in Microsoft Excel in this learning objective. And so let's hop over to Excel and let's look at scatter plots, correlations, regressions, and forecasting in Microsoft Excel. I'll see you in just a moment.
Hey everyone. So I'm going to use this video to walk you through generating visualizations for predictive analytics. If you remember, predictive analytics are all about, given what we know from the current data, what do we expect to happen in the future? And then prescriptive analytics, so there's predictive analytics, which is involving what's going to happen in the future. And prescriptive analytics deal with what should we do, what course of action should we take based on our analyses, right? So we're looking here at predictive analytics, what's going to happen based on what we know. So what I would like to do is I want to see how well does last year's sales predict current year's sales. So what I'm going to do is I'm going to go to CompuStat in Words, and I'm going to go to North America Daily. I'm going to go to Fundamentals Annual. This is where the 10K financial statement data is gathered. And I'm going to look at everything from June of 1950 through today for Ford Motor Company. So let's see. I'm going to say through today. I'm going to look at Ford's ticker symbol here. So I'm going to say Ford. Search is in progress. So we want, so it looks like there's a lot of them to choose from here. So it's definitely not this one. It's not Forward Industries. Could be Ford Holdings. I'm not sure here. Looks like this didn't start until 1985, which is much too late for what we're interested in. So a lot of these companies have like holding companies and other legal entities that they also have to file financial statements for with the SEC. So sometimes it's a challenge trying to figure out which one you're interested in. But it looks like we don't want the credit company. We don't want Ford Motors of Canada. We want this main business here. So this is Ford Motor Company. It has data available from 1950. That's what we're interested in. So let's choose this one here. Add code to the list. Let's do, I didn't select. Okay, so I'm going to check this box and I'm say CIK, add codes to list. It added it. Add codes to query. Okay, so now we have Ford in here. We're going to look at Ford from 1950 through 2021. And let's look at, we want its GV key, we want the ticker symbol, we want the QSIP, we want the CIK. And you'll notice I always select these identifiers because I never know when I'm going to want to match this data to data from some other source. For example, I can get all the financial statement data from CompuStat, which I'm in now, but there's also data on who's on Ford's board of directors. So later on in a separate database, I could match this CompuStat data to data from a database called BoardX, which has information on board of directors names. So I always get as many identifiers as I can to give me the greatest chance of being able to match this data to some other data source. Let's add company name. And let's look for revenue. Do Rev T, which is revenue, which is what we're interested in here. We'll do Rev T. Take a moment. All right, so that's added. We'll go, we want this in Excel. We want our date format, date 9. We're not worried about compressing it. I'm going to submit this, pause the video, and come back once I have it downloaded. Alright, so it looks like the data is now ready. I'm going to open this Excel file. It'll take just a moment. Fire up Excel. I love Excel. I can do anything in Excel. I was watching the Phillies game last night, and they were talking about how they make their, the announcers make their scorecards in Excel, which I thought was pretty interesting. Okay, so we have data for Ford, and we have data all the way through row 72 here, so it looks like we have data from December 1950 all the way through December 2020. We have sales data. So what I want to do here is I just want to calculate what I would call trailing revenue. So it looks like our first revenue data comes from 1952. So what I want to create over here is last year's revenue. Current year's revenue, and I'm going to say last year's revenue. I'm just going to create a basic formula here. So say, let's make this a little bigger so you guys can see. So current year's revenue is, I'm just going to copy this value, and then I'm going to say last year's revenue is going to be equal to the previous year's revenue, right? So this year's current revenue becomes next year's previous revenue, if that makes sense. So this is, I'm going to copy this formula here. Right? So every year we're going to have the current revenue here and then the previous revenue here. And what I want to see is, does this column predict this column? Right? Does last year's revenue predict this year's revenue? Is there some correlation there? So I'm just going to copy this formula all the way down. We'll go down here, we'll go up, we'll paste this. Right? So now we have, and I'm leaving this blank because there is no prior year revenue there. So I'm going to leave that blank. And what I'm going to do, just so things don't get messed up as I start manipulating this, I'm going to copy the whole sheet. Right? I'm going to say copy. And then I'm going to repaste it, but I'm going to say paste only the values. So I'm going to get rid of the formulas that I set up. All right, I'm going to paste over values. So now I have like hard-coded numbers in here. And then I can just delete these first couple of rows because we don't want these in the analysis. We don't have current year revenue for these two rows, and we don't have last year revenues for this row. So I'm just going to delete these first 3 years here. We don't want to include those in the analysis. So now for all remaining data, we have current year's revenue and the previous year's revenue. So let's see if last year's revenue has any relationship with current year's revenue. First thing I usually do is look at a scatter plot. So I'm just going to highlight these, and I'm going to say insert, let's do a scatter plot. And let's see what we have here. So it definitely looks pretty good. Let's check our data to see if, so Excel automatically generated this, but I just want to double check what Excel did. So let's edit this series. It looks like the series name, let's call this current year versus last year revenue. Right? And x-axis, where did it pull from? It pulled from, oh, it's just pulling, okay, so it's putting on the x-axis current year, right? And let's flip this. I want the x-axis to have last year. I'm trying to see if x, right, the x-axis explains y. So I want to know, does last year explain this year? So I'm just going to flip this around. So Excel doesn't always get it right. It got it pretty close. And I think that's all we want. So let's see what this looks like. Yeah, so I mean, this is pretty clear that, you know, for Ford, what the company's revenue was last year is strongly predictive of what it will be the current year, right? So this is a really good visualization. It's suggestive that we have a good relationship here. It looks like we have a really good relationship. Another thing we can do is we can add a trend line here. So let's say trend line. Okay, so this trend line it's representing what the regression line would be. If we estimated a regression, this is what the line would, if you were to like draw the line that is estimated by the regression equation, this is what that line would look like. So this is showing us this is a clear positive relationship. As last year's revenue goes up, so does current year's revenue. So last year's revenue is doing a really good job of predicting current year revenue. So that is another strong indication that we have a good relationship here. Another thing that we can do is we can just calculate correlations. So correlation is a statistical measure that captures how much one variable moves with another variable. So if this goes up by 10, how much does this go up? So that's the idea behind correlation. How much do these things move together? So we can highlight that data and we can go to data analysis. And we can add a correlation here. So let's add a correlation. Input range. Let's highlight these. And we have labels in the first row. And let's put it into a new worksheet. Let's see what we get here. So, I mean, here's our correlation table. What this is indicating is that there is a 0.989. So correlations range in value from -1 to +1. So closer to 1, the more a correlation of 1 means a perfect correlation. Like the two things have the exact same value. Anytime one variable changes, the other variable changes by the exact same amount. So what this is indicating is that there's a 0.99 correlation between current year revenue and last year revenue. You'll notice this is a 1 here. It's because the correlation between current year revenue and current year revenue was 1. Those are perfectly correlated. That makes sense. And same thing here for last year's revenue is perfectly correlated with itself. That's basically what it's saying. But we have a 0.99 correlation between last year's revenue and this year's revenue. That's a very strong statistical result there. We can be confident that this relationship we're seeing in the scatter plot actually exists. It's not just a mirage or anything that we're seeing in the visualization. What else could we do here? There's lots of different things. There's so many different things that we could do with this data. We could run their regression analysis. Actually, let's just do it for the fun of it. So let's do, we'll go to data, we'll do data analysis. Let's do regression, right? And our Y variable is going to be this column. Our X variable, last year's revenue, which explains this year's revenue, is there. What do we have? We have labels in the first row. We're going to put it into a new sheet. Let's see what this looks like. I think so. It allowed us to do that trick for correlation, but looks like for regression we have to be more specific. So what I did was I just clicked the entire column as opposed to highlighting the cells, which is fine. I don't mind redoing it again. Just Excel's quirky sometimes like that. It didn't care when I did correlation, but apparently it cares now. So I didn't highlight the labels this time, so I'll take that checkbox off. Click OK. Here's our regression output. We have 68 observations. Our F statistic is significant. It means the model fits. It works. You'll notice the the coefficient on last year's sales is positive 0.98, so pretty similar to what we saw in the correlation. And the p-value is next to 0, so it's as close to 0 as you probably could get in this test. So this is, again, another statistical test indicating that we have a pretty good relationship here between last year's revenue and current year's revenue. What else can we do here? Sorry, I just paused there because I had a cough. Another thing we could do is we could forecast. So we could, let's go to, so I'm in data, and then I could do a forecast sheet. Timeline's not evenly spaced. Let's see. So let's see, timeline range. 01069, okay. Values range 010. No. So I want this. So I'm just checking the years here. So I'm gonna say, here are my years, right? Okay, that's better. So we have the timeline range here, values range. I'm going to include forecast statistics. I'll fill missing points, that's fine. Okay, looks good. Let's see what this looks like. All right, so here is our forecast, right? So this is, again, we're in predictive analytics. So here is Ford sales, and this, we have data through 2020, and we're trying to predict what sales will look like going forward, and all the way through 2037. And so this middle line is kind of the middle estimate, and then the top line is best case scenario, and the bottom line is kind of worst case scenario. And then, so this is a useful visual. But then if you wanted to see what the actual numbers for the estimates are, you have them here in this table as well. So many different things you can do to do predictive analytics in Excel. Hopefully you find this video helpful, and I will talk to you soon.